Good evening, good day to all. This is Anirban. Today, I intend to discuss on this topic of generating summaries from long pieces of text, which sometimes can take many hours for a scientific community to generate these summaries. Uh, or it could also be in the media industry generating summaries for news articles. My experience on summary generation recently has been for one of the top five corporates internationally, and basically they had a requirement of generating summaries in many different areas, be it scientific reports, be it the summaries of uh, unplanned events during the manufacturing process of various kinds of products that they produce. Sometimes these reports can go into many pages, and what the executives want to see is a short summarized version of this. And being able to generate summaries automatically there meant saving a lot of time for the scientific community and a lot of efficiency in the system. But of course, the key challenge was there how to generate summaries that accurately reflect the long piece of text for a scientific report. And I'll come to that, and also remember an interesting incident from my own career when I was starting up in the AI industry about 4 to 5 years back. And I was looking for work in this area, and I met uh, the senior person in a department where they were doing work in artificial intelligence. And I remember this is the first work that I got. This person called some of his juniors. They were doing a project for I think, for the media industry, and he gave me the task of generating summary for some of the text pieces they had. And I think he gave me about 2 weeks time, and he said, "You come back with a good summary generated using AI, and if you can do that, I'll take you in my department." So I came back. I kept trying a lot of algorithms by training the models, uh, deep learning models, various algorithms, but I didn't get good results. All I was getting some jumbled up words at the end of it, at the end of the huge pipeline. And it also occurred to me that summary generation was one of the toughest problems to solve about 4 years, 5 years back, because I remember attending an international conference on AI at one of the prominent institutions where this expert group from the industry was speaking. And as part of the presentation, they were talking about some of the key challenges which AI has not been able to solve at that point of time. I remember clearly summary generation was one of them, and I went up and talked to them after the talk. So I clearly remember that. So this technology has made rapid strides over the last few years, thanks to the Hugging Face transformers community and the open source technology provided by the Hugging Face transformers. One of the key, I would say, the aspects about these transformers is the Hugging Face transformers is the simplicity to use it. They have made it very simple for the end user to use it. And the second thing is they have made transfer learning possible in a very simple way for the end users, because many a times it happens that one wants to generate summary on a scientific content or something which contains jargons from one's own specific domain. It could be any other technical content, could be in the manufacturing industry, could be in the biomedical industry. So the Hugging Face repository, the pre-trained models that are available for summary generation, they're all trained on plain English kind of text, which is like kind of news articles and things like that. So the Hugging Face also has made this process of training the model uh, uh, very easy with the documentation. There are lots of notebooks provided, and I'll show that from a practical point of view how to use the Hugging Face Transformers pipeline for generating summaries, how to fine tune the model in various different ways, and also how to check the effectiveness of the summary generation, how to measure it with metrics. I'm hoping that somebody who is starting in this area might find it useful. So, having given that introduction, like to go ahead. So, with this notebook, so basically, one of the first things that we do is we install the transformers package. Uh, so, I'm using the Google Colab here. Okay, it's already installed. I installed the Rouch package because I want to measure the Rouch scores after generating the summary. Few other packages that I need, and then I'll be using this news summary dataset from Kaggle. So, given the article link over here, one can download it here. I've just uploaded it to my Google Colab environment. So, I'll just go and read this dataset. So, basically, as we see, this dataset has this text and C text. These are the most important columns in this. So the C text is a we call it in short the long text, that is the elaborated text, and the text is the summarized text. So here I'm printing the 0th row, summarized text, and also the C text. So this should come, the actual text should come before. So here we can read the news article a little bit. So how this is, and we can see the summary generated. I mean, this is not a generated summary, this is a reference summary. This is part of the data set. So this is what the summary should look like. So it's saying that the Daman and Diu administration withdrew a circular that asked women staff to tie Rakis on male colleagues after the order triggered a backlash from employees and was ripped apart on social media, etc., and all that. So if you see the summary is kind of representing that. We can check another such sample. Let's say the 10th element. So we can read this. Let's see what the summary text is for this. Pretty good summary we have here. So now we'll like to basically, there is also a headlines column, but we'll not use it much. I mean, okay. So one of the first things that we do is we create a summarization pipeline. So this is where, as I was saying, the Hugging Face has made generating summaries very simple task. So we just, one of the key features of the Hugging Face Transformers pipeline, what I feel is the simplicity to use it. The complex encoder decoder models with attention mechanisms, and we don't see any of that. They have made it very easy to use for an end user and do their tasks, right? Beat any task. So we can, I have given the link to the Hugging Face pipelines over here. From the Hugging Face repository, we can see there are different types of pipelines. For example, text classification pipeline, text generation pipeline, summarization pipeline, which is what we are going to use, question answering pipeline, the different types of pipelines over here, right? Visual question answering pipeline, and they're getting added. I mean, when I was seeing this pipeline, page last about 6 months back, I think many of these were not there. So these pipelines are getting enhanced continuously. Audio classification pipeline, there are different types of things over here. So when we want to use a pipeline, it's very simple. We say pipeline text classification, for example. Here's an example. And we give the sentence to that pipeline and it comes back with a label. In this case, it is checking the sentiment of that text piece and saying it's positive with a score of 99%. Right? So, with the same way, we are creating a pipeline and we are saying this I want to generate a pipeline for summarization, right? As simple as that. So, once I do that, my pipeline gets downloaded. What it's saying here, no model was supplied, defaulted to Distilbert CNN 12.6. So, here when I'm creating the pipeline, I have an option to select a model, right? If I don't give the model, I will basically get a default model. So that's what it's saying. When we were using, actually this default model also kind of changes. When we were using, the default model was Facebook bot, but right now I see that it is using the default model as Distilbert CNN 12.6. Something happened. The runtime got disconnected, so I'm just waiting for the runtime to come up. So once I've created a summarizer with the pipeline of summarization, I just pass my text, in this case, this particular text, and I get the result. So I've got the result. If you see the result looks like this. So this is a summary which comes in the summary text uh, key value within the JSON. How it looks. You want to sentence tokenize it, that's also fine. Now, once we have generated the summary, one thing we might need to do is, okay, how good is my summary? I mean, that's one of the questions that business will definitely ask, right? So, what we can do is one of the standard techniques for checking the effectiveness of the summary is to compare it with a reference summary, which is generated by business, and getting effective metric score, which can be the Rouse scores in this scenario. So what I'll do is I'll take the hypothesis as the summary, which I have generated now, and I will take the reference as the summary provided as part of this data set, which is this particular summary. This is a summary which has been provided, and once I do this, I can actually get the Rouse scores. You see the scores. So Rouse scores basically comes in various flavors. You have the Rouge 1 score, Rouge 2 score, and Rouge L score. They're slightly different algorithms. Basically, it checks the similarity of the text content, and one of the best practices. So one of the ways that we can do is we can take a average of the Rouge 1, Rouge 2, and Rouge L scores. That's exactly what I'm doing here. So I'm taking the average. The Rouge average is 45.45. So it's a score between 0 and 1. Generally, anything above zero point 0.6, zero point 0.5 is considered a good Rouge score in summary generation. So this is what we got. Now what I can do, now what I can do with this summary generation is I can change my models over here. So some of the important models that we can think about are, for example, the T5 base, which is provided by Google. So the way it is done is basically we whenever we give a model here, we basically we should give the tokenizer here also. The model and tokenizer are two important aspects of any Hugging Face repository model, and we can pick up from a variety of models. If you go to the Hugging Face repository page, we can see models grouped by the tasks they perform. So for summarization, there are multiple different models. So for example, here if I want to use the T5 model, base model, I can do that. So I just use this. I create a summarization model, and I again generate my summary. The important aspect about generating the summary is, as can be seen, I am providing the max length, which is the maximum number of tokens or words which I want in my summary. So it's a 850 megabyte model which has been downloaded, and once it's downloaded, I can now use that to generate my summary. That's what I generate my summary, and I can see the result. I can again check my browse scores in the same way. It's 0.37. It has dipped a little. In this case, the default model gave us better results. So what are the other options of models to check that? We can just check the Google Hugging Face model repository. Once we do that, the first page that we hit, we actually click summarization, and we should see all the summarization models that are uh, available to us. So I remember we use the Facebook BERT a lot. So let me just search by that. Facebook BERT. This is a classification model, so I shouldn't have searched. I need to search. I searched it here. I should have searched based on the results of this. Right. Summarization. Updated 7 days ago. Facebook BERT large CNN. So I can just take up this model and use that as well over here. So this is my notebook. So now instead of this, I can give Facebook bird large CNN. And what's a tokenizer for that call is something which I'll have to look for as well. So one of the good ways of looking for that is just click this, and once you click any model in the Hugging Face repositories, just say EOS, and you will see that the tokenizer is also called the same. You can copy it from here. This is how to use it in any program. So they'll give these few lines of code which can be used to use this model. And this is a good link. In fact, I should give this link over here in my notebook. Okay, so tokenizer is also the same. So 1.5 gig model is getting downloaded. Okay, so once the model is downloaded, so it's important that as we can see that downloading the model can be time consuming. So it's important that we are using this as part of a REST API, and we face this challenge. It should always be in the startup event, not for every method invocation. So now I generate the summary using the summarization pipeline. Once the pipeline has been instantiated, and here also while generating the summary, we found that there is a wide variation in the response time. So this one, for example, a few seconds, it could generate a summary. Let's see the kind of summary we got. This looks quite good to me. The FSAI is in the process of creating a network of food banking partners to collect and distribute leftover food. A notification to create a separate category of food business operators who will be licensed to deal only with leftover food has been drafted. And this is a summary of this entire thing here. This looks to be a very coherent summary to me. I'm expecting a better rouse score. So let's see what's a rouse score. I just took off the text part of it in the summary object, and now I am in a position to get the rouse score based on the summary as part of the data set. So we take the average of the route 1, route 2, and route L, I get 0.38. Looks little better than the previous score, but still less than what the default model was giving me. Okay, this is surprising because the Rouge L and the Rouge 1 scores are quite high, but the Rouge 2 score has dipped a lot. I'm not sure what's the reason, 0.27. That has taken down the average score, right? So you can either go by one of these scores, let's say the Rouge L score, or we can take average of these scores, right? So anyway, so this is how. This one other aspect we can see also here multiple models, and some of these models are targeted towards specific kinds of problems. So for example, if we look at Google Pegasus, so Google Pegasus has multiple summarization models trained, and some of these are very specific to particular domains. For example, the Google Pegasus PubMed, if you look at it, it's a summarization model which is basically trained with basically the PubMed body of literature, which is which is a set of research papers and their abstracts. So it's trained on that. As the name suggests, for abstractive summarization of research articles, right? So we can use that. Or since right now we are working on news data, what I found is Google Pegasus newsroom might make a lot of sense to us, right? So this is updated October 22, 2020. And so I can go here and I can use the Google Pegasus newsroom as well. Instead of the, I can do that also. So I can just change the model here. Google Pegasus newsroom. It's one of the recent models trained by Google on millions of news articles, summarizing the news articles. 2 gig. We can see here it's downloading. And let's see how the summarization looks like with that. Bit slow to download at this point of time. I don't know why. Sometimes downloads quite fast. So as this downloads, let me just discuss on some of the other aspects on how we can uh, fine tune this summary generation process further, right? Because many a times I've seen a challenging situation because the kind of problem statements I saw from the business, it's not always simple news articles that business wants to summarize. There are many other applications, for example, generating summaries of, as I was saying, scientific reports about medicine trials, which can run into many pages. And what the business wants to see, the executive wants to see, is a short summary of that experiment. And getting that summary written by somebody, it cannot be done by a untrained person also. So it's quite an expensive process. It requires a lot of effort, a trained person. And if the summary can be generated by AI, that is something which business wants to see. And we saw huge project, multiple such projects in these areas. We also saw summary generation projects in areas of manufacturing. And now this is not the traditional, manufacturing that we know, machine tools or cars. This is the manufacturing process in biomedical engineering field, where the deviations at the unplanned events description can run into pages, and people want to see what this deviation was at this particular manufacturing stage in a short summary. So that is also something I have seen. And in all these cases, these models which are provided by Hugging Face, the pre-trained models won't work because it contains lots of technical jargons, scientific results, scientific terminologies. So one needs to update the model using transfer learning. And even there, Hugging Face has provided a uh, very user-friendly way to train the model, to fine tune the model, which I'm going to talk about next. So this is what fine tune a Hugging Face repository model on your own corpus using self supervised training. So this process, basically what it means is, we basically we can basically take the samples that we have, coalesce them into one text file, right? All our samples, into put them into one text file, and provide that text file as a training data to the to the Hugging Face repository model, and this is a totally a self-supervised training. So you have only that text to be provided. And what this Hugging Face training process does, what I've seen, is something called MLM, masked language modeling. There are different ways it trains. Basically, it takes a sentence and tries to predict the next word and things like that. So it's all using the same body of text. There is no label provided here. So how to do that is basically very simple. We take the text from this the long text, not the summarized text, the original text, and we just put it in one text field. And once that is done, we just use that. Okay, let me see. I think it is almost there. Once that is done, we can write it into a file, and once we write that into a file, that file becomes the input uh, to my training process. That's all I have to do. So that is what I'm doing here. I think this is done almost. I'll wait a few minutes. I'll see. What I remember is the Pegasus model is very huge, and the summary generation response time is also quite high. So we have to look at the response times also over here. For example, if somebody is trying to do it real time on a web application, definitely this model won't be a good choice because of the response time. It can probably work much better in a batch mode. So it's a combination of effectiveness of the summary and the response time, depending on the application that one is having, that one has to keep in mind. Since the model is downloaded now, I'll give it to generate the summary. We still remember that this model took the maximum time amongst available models. I think more than a minute to generate summary from a reasonable piece of text. And that's what we can see here also, although I'm not timing it, but we can see here the time. It's executing already 48 seconds. Very complex model, more than 2 gigs. So it is done. About 1 minute it took. Let's see the summary. So every case I'm giving the max length as 100. We can specify that. What's the maximum length of my summary I need? So I'll extract the summary field from there, and I'll try to get the route score, average route score, 0.43. It's better than the previous two. It's comparable to the first option that we had. So yes, so I'd like to check a little bit on what the sum will be on Facebook bird base. This is what I remember worked very good for us, Facebook bird base. And I remember quite clearly that this was the default model Hugging Face used to use about a year or two back. Right now it has changed, so I'm just interested to know how the summary will be with the Facebook bird base model. Now, important to know, this is not the BERT text classifier. This is a sequence to sequence model. So I have a sequence of words which is the actual text, and I have the summarized text, which is also a sequence of words, but a reduced sequence, which carries the same meaning, right? So very complex attention-based model. So that is it. So I'll download quite quickly. 1.29. This is a 532 megabyte model, not that huge like Pegasus. I'm expecting the response time to be much less than Pegasus. Okay, generated. See how the result looks like. Okay, looks pretty good to me. I'll extract the summary and then I'll go for the rouse score again and evaluate the average rouse score 0.44. So it's little better than what I got earlier. So that's how it is. This is how the process goes. And so now, as I was saying, in many cases we can't use the pre-trained model because of these technical jargons related to a scientific report. It could be a financial report, it could be something manufacturing reports, right? Unplanned events reports, so wherever it is. So we need to fine tune this model. So how do we do this? Again, I've given the link here. Hugging Face has provided very nice documentation. The important point that I want to say from experience is this process is very simple. Initially it looks quite daunting. How do we train a complex model like a Hugging Face transformers repository model? It's such a complex model, encoder, decoder, attentions, and all that things. But basically, the interface provided is very simple. So all I do is I coalesce the text. I just keep on adding the text into one text file. I'm taking the first 50 rows to make it simple. So this is my text, which I got, and then I write it to a text file, as simple as that. Once I do that, I basically I'll explain this line why I'm commenting and uncommenting this. Basically, I create my model, I instantiate my model, which I want to update the weights. So in this case, a Facebook bot base, I instantiate the model and the tokenizer. And here's what I've learned from experience, that most cases updating the tokenizer is not advisable. It's important that we we check the results carefully, because what we found is uh, updating the tokenizer is not recommended unless one has huge amount of training data, which runs into tens of thousands of samples, right? So if most cases in scientific report generation community will not have that many samples, we may have 50 samples, right, or 100 samples to train with. So in that such a scenario, what we have found, keeping the tokenizer as is and updating the model weights is gives optimum results. So that's what we'll be doing here. We'll be updating the weights of the model, keeping the tokenizer the same. Because when we are updating the tokenizer, the embedding vectors that's going to generate is also going to change, and that is related to the meaning. As we know, the definition, by definition, the embedding vectors of a word is very close to the embedding vectors of another similar word, right? So that relationship has to be maintained when generating those embedding vectors. So if we train that process, it needs to see sufficient examples of those complex words which it's seeing in the corpus, mm, uh, mm, to make sense of it, that which are the similar words, right? So that's why we left the tokenizer as is, and we basically we update the model weights. So here is what I'm doing. Another small thing that which I found from my experience is, if you notice that I'm taking only few rows at a time, and what I found is, like the example that I'm talking about, sometimes what happens, if your text gets too large, this process of creating the data set, the text data set from the text file that we are creating, just by this text file is very simple. coalescing all the data from all the samples that I have into one file. But if that file grows large, then this process here sometimes has a tendency to take a lot of time. The response time increases. So we can do it piece by piece. We can take, that's what I'm trying to show here. And I'll take 50 rows, and then I'll take the next 50 rows and keep updating the model. That's also gives a good results. So I've taken 50 rows of text. Obviously, we can take much higher. Just for saving time and simplicity, I'm showing 50 rows of text. I've created the text data set. I created a data collator object, and then I create my training arguments. I pass the output directory where I'm going to store my trained model, and the batch size, the epochs, and things like that. So I've just kept this to a minimum to show it quickly, and one should experiment more on this. So I've created the trainer with the model, the arguments, which are the training arguments, the data collator, which I've created here, and the train data set. So this is my train data set, which is created from this text file that I have. So these are the basically the arguments of the trainer. Right? It's important to use the GPU over here because this is a computing intensive process. With that done, I just start the training process. Let's see how this runs. So I can see the training is running, which means the model weights are getting updated. We have started from the pre-trained model from the Hugging Face repository, the Facebook BART for summarization, and we are updating the weights of the model based on a corpus of text that we have provided it. Now, we can see the training loss, and we should be able to see the training loss coming down. So it will be printed here every 500 steps. It's also possible to, here I'm updating the model weights for all the layers. We can see this encoder decoder layers when the model is printed here. First we have the encoder layers, then we have the decoder layers, right? These huge layers. And it's possible, what some people also do is they freeze the weights of the initial layers of the model, and they only train the penultimate layers of the model. That's also possible, but it's not mandatory. We can update the weights of the entire model as well. So we can see the layers of the model, the encoder and the decoder layers, right? Attention layers and everything we can see here. So we can see after 500 steps, the training loss was here. We can see the training loss reducing from 0.04 to zero point 0.01. So that is one important indication that yes, the model is training. I'm just doing it for few epochs now. So that is it, the model. Now I just save the model in a particular folder. My model is saved here. Now I can use this model for generating my summarization. Not only that, I can use this model to fine tune again. So if I have a lot of text, that is what I was trying to say, I was trying to simulate. Now what I can do is when I start my training, instead of starting from the pre-trained model provided by the Facebook, I start from the model which I already have saved. So if you see, I'm saying model equal to but from pre-trained, and I'm providing the path where I've stored my model. So I start with this, and now I can take the number of rows from the 51st row to the 100th row and create my text corpus. So my text corpus is different now. And that I write to a different file. I say 51st to 100 rows. write it to a file, and I've already created the model. Now it's important that I'm not starting from the Hugging Face repository pre-trained model, but from the model that I have already trained. And I'm using the file which I have now with the incremental data from my corpus of text. Created this. Path is the same because I'm going to update the model there. Use the GPU for sure, and I train the model once again. So these are the steps. I've given the steps here. Step 1 to step 7. It starts with basically step 1, collect the text from multiple samples into one text file. Very simple. Just keep on collecting the text and write it to a file. Instantiate the model and the tokenizer from Hugging Face repository for fine tuning. Right? If I'm doing it iteratively, for the next iteration onwards, I should actually point to the model which I already have. Right? If the text is too big and I can't handle it at once, which is what I'm trying to simulate here, taking 50 rows at a time. So once I do that, I create the data set, I create a data collator object, I create my training arguments, I create the trainer, right? Create the training arguments for model training, which takes all these inputs and use the device properly, and that's it. Train the model. So I can see the training loss, it was 0.01. It started from that, roughly zero point zero 0.02, and it's going, we can see what happens after 1,000 steps. See, we can see the loss coming down. 0.019, it went to 0.009. So it's done. I again save the model, update the model, and I can keep on doing this iteratively until I exhaust all my data, right? And now I can use this model to generate my summary. So here, when I'm saying model equal to, I'm not giving any model which is pre-trained, but I'm giving the model that I just now updated the weights for. And I'm creating a summarization pipeline. As simple as that. Created that. So it gives all the attributes of the model. These are important attributes. And now I can generate the summary of this 10th sample that we are checking from this news data set. I generated the summary. Let's look at the route score by comparing it with the summary which is available as part of the data set. 0.44. In this case, it didn't improve much. Maybe with more training, it will improve. I was trying with some other data and I found a significant improvement here. So it needs more training. As we train more and more, this route score is supposed to go up. That's a important aspect about it. That's how we evaluate the summaries. And it's important that we get these reference summaries from the business. In this case, I'm just taking it from the data set, the new summary data set, which is from Kaggle. But in actuality, for technical reports, these summaries, reference summaries, are to be generated by business, and we need to check the similarity using route scores. And as we keep on training the model, it should get better and better. Now that is the first part, training the updating the weights of the model in a self-supervised way. The second part of the training is fine-tuning the model further using supervised training. So we can also do a supervised training. We have the XY pairs. For example, if we look at this news summary data set, we have 5,000 rows, right? Roughly, and each of these has the news and the equivalent summary. So if we see here, so we have the C text, which is the full uh, data, the long piece of text, and the text is basically the summarized version of it. So we can check, right? We can check any one, this thing, df C text. So this is the C text, Supreme Court and all these things, allowing the provision Rajya Sabha polls in Gujarat, something with Supreme Court, and we can check what's the summarized version of that. Summarized is this much only. The important aspect of that news, that's only there in this. So we have these pairs, right? So we can use this for supervised training as well. Now, the self-supervised training is needed only when we have a corpus of text which has a domain-specific corpus, lots of technical jargons, terms which the Hugging Face hasn't seen earlier. But if it's plain English, but let's say in a different domain, but using plain English language, we can skip the self-supervised training. We can just go to supervised training. The only aspect about supervised training is it requires a whole lot of data. I mean, it doesn't make a lot of sense to have 20 samples or 50 samples and do a supervised training of such a complex model. So the example that I'm showing here, it's basically given by Hugging Face. These examples are given. They are using this news data set only, and it has 4,500 examples of news and the equivalent summary. And they're using part of that for training and part of that we are using for validation. So this is the notebook I initially followed from the A. Mishra tutorials. Very good notebook. And Hugging Face, the one of the things I've seen, Hugging Face keeps coming up with lots of reference notebooks. If we go to this page, Transformers Notebooks, we can see lots of examples on how to fine tune a pre trained model, PyTorch examples, how to fine tune a model on question answering, how to fine tune a model on summarization, lots of examples. They keep on adding. I mean, I came to this page after a few months and I find lots of new things over here. The one example that we used initially was from this source code provided by Abhi Mishra. It's a very good source code which was referred by the Hugging Face at that time. And I made some changes to that because being 3 years old, some of the APIs have changed slightly, what I found when I was trying to run it. So I created my own version of this by making minor changes in this. So what it does, basically, I'll give the idea. So it takes this mm, text and the summarized text version. So these are the long pieces of text and these are the summarized text. Just printed some samples. So it does take that and it basically gets the tokenized basically IDs, the token IDs from there. So there are different functions. One is creates a custom data set, which basically takes the data set and returns the source ID, source mark, target IDs, and the target IDs Y. So what is the source set of sequence and what is the target set of sequence? It returns that. There's a validate function which basically generates the predictions and returns the predictions and the target, right? And then there is a generate summary, which basically generates the predictions from the trained data set. That is what it does. And then finally the train method, which basically propagates the loss. So it generates the outputs, right? Based on the and based on the labels provided, it calculates the loss. So then says lost or backward. So basically that is how in PyTorch we Hugging Face uses either the PyTorch or the TensorFlow. Either of these frameworks can be used. Here we are using the PyTorch. So this is the input IDs based on which it is generating the predictions of the summaries, and based on the labels provided, it's basically creating the loss function and propagating the loss. So once this is done, this can be, so we can see here we are only using the text and the C text, the actual and the summarized text. And basically we are giving the batch size, the validation batch size, all these, creating the train data, which is 80%. We're taking 80% of the data as train data, validation data remaining, and that is it. The training loader, from the training set, the validation loader, the model, we can use any model to start with. Here we are using the T5 base to start with, and further update our weights using supervised training. So using Adam optimizer over here, right, a learning rate which is given at the top here, 1e minus 4. And this is as per this notebook provided by Hugging Face community. I'm doing this, just some small changes here and there. Once the training is done, basically it takes the data from the validation set and writes the generated summaries into a file, into a CSV file. So we can see as the training is going on, the loss we can see here is coming down slowly. We can see that just trained for 2 epochs. It's a compute intensive process. GPU is a must over here. And once we do that, we can again save this model. I'm not doing this online because it will take time. So we can, same way, we can save the model into a folder of our choice, and we can basically check some of these samples, how it is generated. And what the important thing about this is, we can now use this model to generate our summaries using the Hugging Face transformers pipeline. And we can see an example of summary generated. So these are the two ways we can fine tune the models, which we have used realistically in our projects and got appreciation and even got an international award. We did a lot of things on top of this, it was a teamwork, and it was appreciated, and it is being used by customers in real production. And one other important aspect which I have seen from my experience when I was applying it is this combination of extractive and abstractive summarization sometimes makes a lot of sense. Why? Because let's say we are trying to summarize the contents of a PDF, right? And this PDF is running into, let's say, 20 pages. Now, Hugging Face transformers models, most of the models take a maximum of 1024 tokens or 1024 words. Some of these models also take 512 tokens or 512 words as an input. That's a max. Now, if we don't do anything and provide this entire text content from the PDF, which is running into 10 pages, what happens is it will automatically truncate and it will take the first 1020 tokens. Now, think of it that if somebody is communicating something from outside in a PDF to your company and you want to summarize that, the first, 1 page or 2 page, what will it have? It will probably have the address of that partner. It will have some greeting words, greeting sentences, and then the actual content will start. The actual content may be somewhere in the middle, but you're not going to get that because Hugging Face is going to truncate without any information. It doesn't know. It knows that it can only take maximum of 1024 tokens. So it's going to truncate, I think, the first 1024 tokens. Now that's not going to help us. So what I have done is I have used a combination of extractive and abstractive summarization. So what I'm trying to show here is I'll be using summarization to generate an extractive summary, and getting a summary which gives me this extractive summary, which means it retains the original sentences in the actual document and gives me a summary which is about 1000 tokens, 1000 words. And then I know that I have got the synopsis of that document with this simple tool. I will use that as an input to generate a 100-word summary using Hugging Face, which means I'm using the main content of the document as an input to the Hugging Face repository, some pipeline. So that's what I'm trying to show here in this last part, which is a combination of extractive and abstractive summarization. So here is this method which generates extractive summarization using given a big document, and here is the method which gets a summary with the summarization pipeline which we just now discussed, but it does reduce the sample before that. So this reduce basically uses the get extractive summary, which is the method defined above, and it tokenizes this output, and this uh, is then used as an input to the Hugging Face repository transformer pipeline. So having said that, now I will, yeah, so I have done this. So this, let's say this is a big document I have talking lots of things about coronavirus in detail, and I will use this. Now I will pass this to a method which says get summary, and it says that this is a summary. Coronavirus is a large family of viruses. In humans, several common cold, etc. And this thing, the most recently discovered coronavirus causes this COVID-19. So, so, so that is what it is. So basically, what it is doing is this line is not required. So many a cases, a combination is the best choice because of this inherent problem that I said, that sometimes we may get a piece of text which is like spanning several pages in a PDF, maybe 40 pages. So what Hugging Face is going to do is it's going to truncate that, take the first 1,000 tokens and generate a summary on that. But that's not what we are looking for, right? We are looking for the main component of the text. So we might want to generate a extractive summary, giving it a number of sentences that we want. In this case, I'm taking 10 sentences because I've kind of figured out that 10 sentences are equivalent to 1,000 tokens. And because in extractive summary, we cannot specify the number of words, we have to go by sentences. So, and then using that to as an input to the summarization process in Hugging Face. So, these are some of the techniques that we have seen have given results and are being used by businesses. Fine tuning of the weights in the Hugging Face pre-trained models with a self-supervised approach, supervised training using XY pairs, combination of extractive and abstractive summary. And finally, there is this important aspect where I am coming back to this later because I think this should be tried out less frequently. That's why I'm coming back to this later. So when I'm doing the summarization pipeline here, there are a few parameters. I just talked about the parameter max length, right? Once I created my summarization pipeline using my model of choice, in this case, the Facebook bird base, I'm just changing the max length to generate my summary within that number of words. But here, there are few other parameters which can be changed at our disposal, and these are very technical parameters, like for example num beams, top k, top p, length penalty, no repeat engram size, and things like that. And I can show that sometimes those can give better results as well. So if I use this, it'll change, and we have to find out which is a better summary. If you want to know what are these parameters, one good place is, which I've given the link here, is this over here, this link where these parameters are basically described. Mm, yes, summarization pipeline. I am not able to find this particular place where this I thought I have given this link. but somehow it's not coming up here. Let me see. Top. Ah, top K. Right. These are explained here. Text generation pipeline. So it should be there. Uh, we are still in a different pipeline, so we should go to the summarization pipeline and check for this. Now, once I come here, so not this one, there, here. So somehow I'm not able to find it right now. I'll update that. So basically, these are some technical parameters. For example, the length penalty. Basically, it talks about how to restrict the length, and if the giving a penalty for that. Default values are there for this penalty. Yes. This is not the exact place. I'll update this link later. So where all these parameters, these are basically the number of beams in beam search, the no repeat engram size. If this is specified, it will check for repetition of engrams of that size, and basically make sure that engrams are not repeated. The top K and top P are again statistical terms, temperature. So these are some of the parameters which can be played around with also to fine tune the summarization process. Uh, I'll check this link and make sure I have given the proper link. I was having it somewhere, but somehow I have missed it. So these are the things I wanted to talk about today for the summarization process, and what we have found very useful in industry. And as I said, summarization technology has made rapid strides in the last few years and are being used in many places in industry where the time consumed to generate this summary is high and requires trained people. And in those cases, automatic generation of summarization can lead to a lot of business value. And Hugging Face repository is one good place where one can look forward to generate such summaries, because it provides not only the tools, it also provides very efficient tools to fine tune the models towards one's own domain, uh, using just few lines of code. With that, hope it's useful to some who are starting in this area. Thanks all.